Hi everyone. Today we'll talk about the Intermediate Value Theorem. To help us understand and remember the theorem better, I have an exercise for us. I strongly suggest that you try this exercise on your own first. You can download these notes using the link in the video description. That way, you will understand and remember the theorem better. We must draw a function f of x on the interval from 0 to 4 that satisfies all these three conditions. First, the value of the function at 0 must be 0, and the value of the function at 4 must be 3. So I add the points with coordinates 0, 0 and 4, 3 to the graph of my function. Then the function must be defined for all the numbers in the interval from 0 to 4, and the graph cannot cross the line y equal to 2. There are various ways in which you can do it. You can do it in the following way. This graph is defined for all the x's between 0 and 4 and doesn't cross the line because that dot is open. You could have done it in the following way. This function is also defined for all the x's between 0 and 4 and doesn't cross the line y equal to 2. You could have done it in the following way. Again, all the conditions are satisfied. I have a similar exercise for you to try. This time, the only difference is that the function must be continuous. I suggest you stop the video and give yourself a minute or two to try it on your own. I know that the function must have the coordinate 0, 0, a point with coordinate 0, 0 on it, and a point with coordinates 4, 3. Then the function must be continuous and not cross the line y equal to 2. If I try to draw it, I believe that at some point I will have to cross the line y equal to 2. You could have tried the following. However, this is not a function. For one input, you have two outputs. This function does not pass the vertical line test. So in fact, this is not a function. So I'm worried that no matter how you try to draw this function, if the function is continuous, you will eventually cross the line y equal to 2. In other words, there will be a point on the x-axis, somewhere between 1 and 4, whose value will equal where the function has the value of 2. This is exactly the statement of the Intermediate Value Theorem. To understand this theorem, while reading it, I will be drawing the corresponding picture. We are given a continuous function on the closed interval from a to b. Let me add that closed interval on the x-axis. I have a, I have b, and I know I have a function on that closed interval from a to b. So the function will start somewhere and it will end somewhere else. I know that the y-coordinate of the first point is f of a. The y-coordinate of the second point is f of b. According to the Intermediate Value Theorem, if z is any number strictly between f of a and f of b, so if z is somewhere here, let's say z is right there, then there exists at least one number c in the interval from a to b. There must be some number in here such that the value of c equals to z. Let's see if that is the case. If I draw a horizontal line z, that horizontal line will intersect the graph of the function somewhere. That corresponds to some value between a and b. Let's call that value by c. Note that at that c, the value of the function is z. This theorem is often used to show that certain functions have 0 places or have roots. This is exactly what the next problem is asking us to do. We are given a polynomial, and we are supposed to show that it has at least one root on the interval from 0 to 1. In other words, we have to show that this function crosses the x-axis. There is a place where the value of the function equals to 0. If you would like to try this exercise on your own first, this is a good time to stop the video. To help us understand what we are doing, I'm going to start with a picture. I add the y-axis and I add the x-axis. I am interested in the interval between 0 and 1. So I have an interval from 0 to 1. Now the function f of x is a continuous function. It is a polynomial. So intermediate value theorem applies. If I can only show that there is a place in the interval from 0 to 1 where the function is below the x-axis and a place where the function is above the x-axis, by the intermediate value theorem, the function will have to cross the x-axis. In other words, there will be a place where the value of the function is 0. The function will have at least one root. What happens at 0? If I plug in 0 to my function f, I believe I get -1. So I know that at x equal to 0, the function is below the x-axis. What about at 1? If I plug in 1 to my function, I get 1 to the third power plus 2 minus 1. Well, that is 2. So at x equal to 1, the value of the function is positive. Because the function is continuous, intermediate value theorem says that somewhere between 0 and 1, the function will cross the x-axis. So by IVT, intermediate value theorem, there is c in the interval from 0 to 1 such that the value of the function at that c equals to 0. In other words, the function crosses the x-axis. We don't know exactly where that c is, we only know it's somewhere between 0 and 1. To see if you can do this problem or a similar problem yourself, I have another one for you. We are given a function e to the power x plus x minus 5. We want to show that this function has at least one root. If you would like to try this on your own, stop the video now. I start the same way. I draw the y-axis and I draw the x-axis. This time I'm not given an interval. So I need to decide for myself what axis I would like to choose. I know that this function is continuous. It consists of a combination of 3 continuous functions. So intermediate value theorem applies. I'm going to see what happens at 0. When I plug in 0 to my function, I believe I get e to the 0th power plus 0 minus 5. That is 1 minus 5, so that is -4. So at x equal to 0, the value of this function is negative. So I know I am somewhere below here at -4. I need to find a different x now for which the value of this function will be positive. I think a good x to try would be 5, because then 5 minus 5 would disappear and I would get 0. So I get f of 5 equals e to the 5th power plus 5 minus 5, which gives me e to the 5th power. E is a positive number, it's roughly 2.7, so raising it to the 5th power gives me a positive number. So I know that at x equal to 5, the value of the function is positive. Because this function is continuous, I know that it will have to cross the x-axis somewhere between 0 and 5. So I know that by the intermediate value theorem, there is a c in the interval from 0 to 5 such that f of c equals to 0.